All right, so here we're going to be talking about rational expressions and how to simplify a rational expression. All right, so first off, the definition of a rational expression, it's a fractional expression in which both the numerator and denominator are polynomials. All right, so remember, a polynomial is numbers multiplied by x's raised to powers where those exponents are positive whole numbers. All right, so if I have a polynomial in the numerator of a fraction and another polynomial in the denominator of a fraction, that's what we call a rational expression, right? Rational as in ratio, as in having a fraction. All right, so rational expression, that's what it is. When we want to simplify a rational expression, well, we do kind of the same thing that we do when we try to simplify just a normal fraction, right? We factor the numerator and denominator, and we cancel out any common factors that they have, and then that allows us to simplify our expression, right? So a couple examples here that we'll look at. The first one, just simplifying a basic fraction, just to remind us of how we simplify fractions. And if you haven't watched my videos about fractions and how to work with fractions, you might want to look at those before you look at any more about rational expressions, because a lot of the things we do with rational expressions, whether it's simplifying or multiplying or dividing or adding or subtracting, it's the same rules as what you do when you work with fractions, just fractions with numbers in them. It's just a little more complicated because now our fractions involve variables and algebraic expressions, but the rules for simplifying, multiplying, dividing, adding, subtracting are the same rules as fractions. So again, if you haven't looked at those videos about fractions, or if it's been a while, maybe you want to review those before you look at this stuff with rational expressions, just to remind yourself of what to do with fractions. All right, so anyway, let's simplify these two examples here. So for the first one, 6 over 10. I want to simplify that fraction. So the first thing I want to do then is factor both the numerator and denominator. Right? So 6, if I factor 6, that's equal to 3 times 2. Right? If I factor 10, well, 10 is equal to 5 times 2. Right? So I factor my numerator and denominator, and then I look to see if they have any common factors. And both my numerator and denominator have a factor of 2, so I can cancel out that common factor, and then that leaves me with a fraction 3/5. Right? So 3/5 is a simplified form of 6/10, canceling out that factor of 2 that I had in the numerator and denominator. Right? So that's how we simplify a fraction. When I go to simplify a rational expression like in example B here, x squared minus 1 over x squared plus x minus 2, I'm going to do the exact same thing. I'm going to factor the numerator, I'm going to factor the denominator, and if they have any common factors, I'm going to cancel them out. All right? I just have to remember how to factor. So again, I did some videos about factoring, so if you haven't looked at those, you might want to go and review how to factor. Factoring is one of those things that comes up in a number of different contexts when you're doing algebra and precalculus and calculus. It's a really important skill to have. One of those contexts where we use factoring is when we're working with rational expressions and trying to simplify them, but factoring comes up in a lot of other things as well. All right, so I want to factor my numerator, x squared minus 1. All right, so there's two terms there. Do they have a common factor? Well, no. We have an x squared and we have a minus 1. They don't have any factors in common. So we have to identify what type of expression we have there so that we can factor it. And hopefully you notice that this is a difference of squares. Right? X squared obviously is x squared, and 1 is 1 squared. And it's a difference because those two are being subtracted. And so when I factor a difference of squares, I do the square root of each part. So the square root of x is x, so I put the x in the first spot of each parentheses. The square root of 1 is 1, so I put a 1 in the second part of each parentheses. And then one of them gets a plus and one of them gets a minus. All right, so x squared minus 1 factors into x plus 1 times x minus 1. All right, and if that's not familiar to you or you don't feel that good about that, I did a video about special factoring formulas, and this is one of those special factoring formulas with a difference of squares. So you might want to go find that video and review those special factoring formulas. The difference of squares is one that comes up all the time, so it's really important to be able to identify that x squared minus 1 is a difference of squares, and that factors into x plus 1, x minus 1. All right. The next one here, x squared plus x minus 2. All right, so now I need to factor x squared plus x minus 2. Well, this one is a trinomial. Right? There's 3 terms here, and it's a 1x squared. So this is going to be one of those easier types of trinomials where I can just go right to my 2 parentheses. Right? The x squared breaks up into x times x. And then to fill in the second spot of each parentheses, I need to find 2 numbers that are going to multiply to equal that negative 2 and add up to equal that positive 1 that's in front of the x. Right? So 2 numbers that multiply to negative 2, add up to positive 1. Well, those numbers are going to be positive 2 and negative 1. Right? If I multiply 2 times negative 1, it equals negative 2. When I do my foiling and I do the inner and outer terms, I get a positive 2x and a minus 1x. That adds up to that plus 1x that I have in the middle. Right? Remember, after you factor things, if you want to double check them, you can multiply them back together, in this case for both of these using the FOIL method, to show that it does equal the things that you started with. So if you're not that confident with factoring, especially if you're doing like a quiz or a test problem and you have some time, you might want to, after you factor, multiply it back together just to double check that you did it correctly before you proceed with the rest of the problem. All right, but once we do that, we then look at our factored form, just like we did up here with our 6 over 10, the 3 times 2 and the 5 times 2. I canceled out that common factor of 2. Here, well, I have a common factor of x minus 1. Right? Both my numerator and denominator contain a factor of x minus 1, so I can cancel out that common factor just like I canceled out those 2's up above. And then what I'm left with is, well, I have an x plus 1 in the numerator, and I have an x plus 2 in the denominator, so I get x plus 1 over x plus 2, and I cannot factor that any further. Right? That is as factored as that will be. All right, so hopefully that made sense. When you're trying to simplify a rational expression, just like when you simplify a fraction, you factor it, you look for common factors. If you have common factors, you cancel them out, and then whatever's left is your answer, pretty much. All right, so a couple things though. When I have this in the factored form in the numerator and denominator, I need all my factors to be in parentheses. But then when my final answer, notice I did not put the x plus 1 or the x plus 2 in parentheses. Since there's no other factors on the top and the bottom, I don't need to keep the parentheses around those things. It's not wrong to have them there, it's just extra stuff that's unnecessary. Right? So if there's only one factor left, you can drop the parentheses around the factor. If you still had 2 factors in the numerator or 2 in the denominator, you would need parentheses still around each one of those factors that you have. The other thing here, a lot of people see this and say, well, I got x plus 1 over x plus 2. Now I can cancel out those x's, and this is equal to 1/2. Remember, you are not allowed to do that. Right? If you think you are allowed to do that, go back and look at some of the videos I did about fractions where we talked about simplifying fractions and the rules for dealing with fractions. Remember, you can only cancel out stuff in the numerator and denominator when you have multiplication there. All right, so like going back to this original problem here, the x squared minus 1 over x squared plus x minus 2, I cannot just cancel out those x squareds, right? That's not allowed when that x squared is being added or subtracted with something else, right? I'm not allowed to do that. I can only cancel things out when the thing I'm canceling is being multiplied by the rest of what I have, right? The x minus 1 is multiplying this x plus 1. This x minus 1 is multiplying the x plus 2. When I have multiplication, just like here with the 2's times the 3 and the 5, now I'm allowed to cancel those out. Right? When there's addition here, x plus 2, x plus 1, I am not allowed to just cancel out the x's. Right? Remember, there's different rules for addition and subtraction than there are for multiplication. And a lot of times we're allowed to do more things when we have multiplication that we're not allowed to do when we have addition or subtraction. And this is one of those cases. Right? I'm not allowed to cancel numerators and denominators when I have addition and subtraction. I am allowed to do it when I have multiplication. That's why we factor. Right? That's why it says to simplify a rational expression, we factor the numerator and denominator. Once it's factored and we have multiplication there, that's when we're allowed to actually cancel stuff out. Right? Think about this again. Go back to that 6 over 10. Right? So I could split up 6 over 10. I could say, well, 6, that's 2 plus 4. And then 10, well, that's 2 plus 8. And let me cancel out those 2's. So 6 over 10 is equal to 4 over 8. It doesn't work that way, right? 6/10 is not the same as 4/8. Right? So if the other things I was just saying didn't convince you that you're not allowed to cancel out the x's, this should, right? If I split this up with addition and then I try to cancel out the 2's, I get a fraction that's not equal to the fraction that I started with. I can only cancel those out if I have multiplication there, right? Whether it's a fraction that just has numbers or one of these rational expressions with the algebraic stuff in there, the same rule applies, right? I can only cancel if I have multiplication. It doesn't work with addition. I spent the last 2 minutes talking about that because I've taught algebra classes before, I've taught calculus classes, I've taught precalculus classes. I've seen a lot of students get this and cancel out the x's and try to tell me that this equals 1/2. It doesn't, right? Or go back here and say, well, let me cancel out the x squared, so this equals negative 1 over x minus 2. That's not right, right? Don't do that. You can only cancel out numerators and denominators if you factor it and have multiplication there. All right, so that is simplifying a rational expression. Factoring is a super important skill to know. So if you're still not good on factoring, go back and watch those videos on factoring that I did. Find some practice problems to do where you factor, because it's going to come up not just with rational expressions, but with a whole bunch of other stuff that you're going to see throughout algebra and precalculus and calculus. You're going to be factoring all the time. You need to know how to do it. It's super important.